Another draft physics video production. Having to do it over again. A little computer glitch, blah blah blah, mostly my fault. And such. Just irritating. Yeah, once you've already done a video, it's no fun doing it a second time. So anyway, there were a couple of other comments that I deleted that were useless, so I just mentioned them just to account for it. Somebody said there's no whatever red and black electrons in boats and such. And yes, it's an analogy. There's no boats, and they're probably not red and black and all that stuff. They're just used for the purpose of illustration, just like other people like Leonard Susskind use water to describe gravity. And yeah, he doesn't really think it's water. I don't know what he thinks it is, but whatever. So yeah, better just to delete that crap anyway. So the other comments, whatever. Truth was in front of us all along. You are one put puzzle pieces together. They should award you Nobel Prize. Yes, that'll eventually happen. It seems inevitable. Whether I'm alive or dead is the question. How long it'll take and all that kind of crap. But clearly, if I'm right, it's yes, I've done something rather miraculous. Yeah. Completed Einstein's life's work and all of that kind of crap. So yes, there's no way to really avoid the fact that it's a meritorious accomplishment if that's what I've actually done. Just is. So there was some kind of rag comment, and then there was this other one. It's all about stupid badges, credentials, and kissing someone's ass rather than quality of work and reasoning. Well, that's not really what it's all about. I mean, the function of rewarding people for doing positive, productive things is a good idea. Frankly, there should be a lot more prizes. Instead, we spend $1 zillion on stupid Olympics that rewards people for jumping up and down the best and doing other silly shit like just running faster than everybody else or some other kind of crap. I mean, absolute crap. Okay, we spend literally a million times more money is invested in stupid human behavior than is invested in meritorious behavior, and that's really, really dumb in my opinion. So there should be lots of prizes to be won for meritorious accomplishment. Even in day-to-day arguments, they always bring quotes of some authorities and dismiss rational positions with ad hominems or irrationality. I don't know if that really happens. They really don't get to have too many fair fights with the elite and all of that kind of crap, and the politics is made for common denominator. Everything has to be dumbed down, and even science is dumbed down in that sense. So yeah, there's lots of flaws in the system, and I've pointed that out before, that intelligent people should demand a system of science that has a little bit more integrity than the system we have now, which obviously just, screw the evidence. We don't need evidence. If it just sounds really cool, it's the new theory. So it's pretty bad. Obviously, they've given Nobel Prizes to people who don't deserve them, and, in my opinion, and they've given them to people who do. People who invented something, blue LEDs or something. It's okay. I don't know if it's worth a Nobel Prize, but I mean, at least it's some kind of innovation that has some kind of real tangible merit. But some of the theoretical physics, I think, they've given prizes to nonsense, and certainly the gravitational wave thing is just a huge farce and sham, and that certainly shouldn't have gotten any prizes. But whatever. It's not a fair fight, but there should be a fight. There should be an obligation to win. Do better. And yes, the system sucks at deciding what a better is. So, but what are you going to do? I mean, it's a system full of cowards. They're all trying to protect what they've got, and you see it in politics and you see it in science. So anyway, Jason, so now that I've read this comment, I might as well read the last line first, just so we know that this was all kind of a waste of time. Anyway, in any case, I haven't seen you tackle this problem yet. Well, there really isn't a problem. Curious to see your response. You've obviously given this way more thought than I have, but you're obviously not taking that into consideration at all, in the sense that you're doing all of this on pretty false premises that I have already dealt with. But whatever. Lissage gravity poses another problem besides drag. No, it really doesn't. Drag was the big one, and then I found it even challenging, difficult, to reason your way out of it, until I realized that matter's really made out of electrons and protons. And when I thought about them, I realized, yeah, they do drag to a halt. They don't go anywhere. They always do decay. They always do lose their velocity. So they are dragging to a halt. So drag is really there. And somehow atoms get around it. That is nuclei. The smallest thing we can move at this, at a very fast velocity where it maintains its velocity, where we could actually shoot it somewhere in space, is something like a cosmic ray, which is made out of nuclei, of helium, mainly. And so somehow the complex stuff is able to do what the simple stuff can't. And that's the key to understanding it, that the complex stuff can have an engine. It can have a motor against the speed of the current. Anyway, if gravity comes in bits moving in straight lines at the speed of light, yes, that would be the idea, then how come the force is so dense? So this, its density is, as described many times, as I've attempted to illustrate, but and is illustrated by other arguments you could make. See, he thinks that, okay, so if I had a box and I threw a bunch of BBs into it randomly, okay, and the BBs perpetually move. They don't lose their momentum, and they don't really hit each other. Let's just imagine, but they could bounce off the box. But anyway, the idea would be is that there would be BBs bouncing all over the place, and the point would be is that there's really no place the BB could go to hide from the force. That is, in any of these open spots, there'd be just as many. If I put something in here, just as many BBs are going to hit it here, it's going to hit it over here, it's going to hit it over here. There's no dead spots. There's not more BBs here and less BBs here. There's all the same amount everywhere. And only when you get right next to the surface could you imagine a place where, oh yeah, more of them are going to hit him on the outside, because there aren't any coming in here to push him out this way, so he would stick to the sides. But we're going to consider this a really, really big box, so we're not playing with the edges. Anyway, so it's the quick description. So he's thinking that somehow there's a place you can go where there's less light. Another example would be as if I made a big room and I put lights on all the sides of the room. There's no place you can go where you're going to get less light or more light. So if the light's coming from all directions, there's no place you can go, because if I get closer to one wall, you think, well, okay, I'm getting hit by a lot more intense light because I'm closer to that light. But you're further away from the other light now, so you're getting hit by less photons from those other places. But you're getting hit by less from more directions, from more of those light bulbs you're exposed to, because the closer you get, then you block off all the light above you and below you. You're not getting hit by any of that light. You're just getting hit by the light you're really close to. And it all works out, and especially in spherical symmetry. So if you make the room a sphere, there's no place you could go in the sphere. So if the sphere is producing lights, there's light bulbs all around the sphere, and you're on the inside. There's no place you can go where there's less light. There's always going to be the same amount of photons are going to hit you, because if you get closer to one bulb, you're getting further from the other bulbs, but you're getting exposed to more bulbs. So that's something both me and conventional physics agree on as a fact. That's why there's no gravity, theoretically no gravity, that is no effect, no gravitational effect. If you could make a spherical Earth and just dig out the center, and you could walk around, you could move around the center, it'd be all zero gravity no matter where you went, because you're getting closer, you get to one side, the further away you get to the other side, but you're exposed to more of the other side. All right. Shouldn't it have been diverging at the inverse square law? See, it makes this sound like it's a real argument by throwing the inverse square law in there. Yes, it doesn't matter though. The inverse square law is exactly the point. That if there's 2 points in space, if there's 2 places here, okay, and we think of these as infinite planes or whatever you want to think of them as. All right, and you move, you're here and you move this way. Well, yeah, you're closer to this, but I see that it's a small amount of exposure now. So all you're getting exposed to is this. Where from this other side, you're getting exposed to this. So this big triangle is inverse square lawing, and this one is inverse square lawing. So this one's giving you a lot of, because you're close, you're getting hit by a lot of dense lines, but you're getting hit by a lot more from this weak side. So it's going to end up being exactly the same as it will be here, as it will be here, as it will be here, which will be 0. You'll get hit by as much light from the right as you will the left, no matter where you go. All right, shouldn't inverse square law, wouldn't that create more and more dead spots between the rays? So it's like saying there's dead spots in cosmic background radiation. Now they do show that silly picture of cosmic background radiation where they have it fluctuating. But the fluctuations are 10 to the minus 28 or something. There's a tiny amount of fluctuation. So the light bulbs are not off and on. There's not space where there's not places in the universe you go where there's less background radiation in any real sense. All right. How can they be so dense? So again, it's a container, and there's no way to escape it. Their stuff is there. It doesn't pile up in one place. It doesn't. It goes everywhere. Why don't we observe gravity itself, but only its shadows follow the inverse square? Why don't we observe gravity itself? Well, that's like saying, why don't we observe photons itself? We never see a photon, ever. And when you see a laser beam, you're not seeing the photon that's really going where the light's going. You're seeing the photons that aren't going to make it. You're seeing a photon that isn't in the laser beam anymore. It's just a fact. We can't see photons. Can't see force. Can't see the energy. You only see its effects. But only see its shadows follow the inverse square law. Whatever. I don't know, a Lesage point of view. I'm just saying there's absolutely nothing wrong with Lesage theory in terms of mocking gravity. So again, your argument is that somehow the flaw is in that it doesn't mock gravity. Of course it does. Feynman conceded that overtly. It's a perfect description of gravity. It's just this drag thing was the only thing Feynman saw wrong with it. And as I pointed out, I've solved the drag problem. If you have any volume of space with force bits flying in random directions over time, straight lines are going to diverge. Again, how is that relevant? They're also going to converge. So the fact is that if I could create, theoretically, even the stars, you could just use stars as an example. If we just put the stars everywhere, blah, 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 and they're all creating divergent energy. They're all creating rays that diverge. All right, and the stars are everywhere, and they're just all spraying this little star energy, from all directions. Right? Doesn't matter where you are, okay? Because you're going to be, yes, you only get hit by one ray from that star, and only you get one ray from that one, and one ray from that one, and it all converges on you. So any random field I create of energy, coming from all directions, like the cosmic background radiation, from my perspective, no matter where I go in space, it's all going to look like it's heading right for me. All the stuff that hits me is heading right for me. It's all converging on me from all directions. That's what the randomness will produce. So the random stuff, yeah, it's flying all over the place. It's going everywhere. But the stuff that hits me is not going to be going everywhere. It's going right through me. I'm in the point where the lines are converging. So the point is that they're just lines. So you're just having a bunch of lines going in all directions. And what you're saying is that there's some point in here where there's less lines. Well, there's no point in here where there's less lines. It's all the same number of lines everywhere. All right. Lines are going to diverge. This doesn't seem to be happening. So this is your seam problem, but no, there's no seam problem. If you really thought about it, you'd realize, there's no hope for what you're saying, blah, 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 blah. Their density seems to be quite uniform, and it should be, and why wouldn't it be? This actually poses a problem to your model, says you, with absolutely just kind of a false premise as what you're backing it up with, that other models, waves, dual ether, don't have to deal with. Well, other models don't deal with it because they don't have an actual physical entity creating the mechanism. So, but I don't know, there's no wave theory of gravity as far as I know. I mean, there's no rational one so I'm not going to argue that. Obviously, the reason why bent space doesn't have to deal with it is because bent space isn't a physical thing. So it can't have drag, it can't have anything because it's not a real thing. It's a fake invisible man thing that just pulls stuff in. But clearly when Susskind teaches it, he teaches it exactly like this. This is what he's going to teach. There's no bent geodesic. There's the inverse square law and a convergence. He calls it an anti-divergence, but he basically just says this is fluid. The fluid comes in out here, okay, and it goes down a drain inside the little bit of matter, and that's basically how he teaches gravity. So again, it's no problem here. They don't have a force. Obviously, they don't have to account for anything if you don't have an actual mechanism. Now, Susskind doesn't say there's an actual fluid, so he doesn't have to worry about drag. Don't have to deal with. So I find it strange that there hasn't been more discussion about this subject, and discussion in what form. Again, it's a false premise first that there's any kind of dead spots in a random field that would be created by like the cosmic background radiation. Like you could go somewhere where there's no cosmic background radiation. There's no reason to think so. So it's a false premise, and then it's arguing false notions that somehow, again, that your expectations are based on some notion of what a random field creates that I can't understand. Don't have to deal with it. So if let's see, don't discussion. Yes, so to finish that. Okay. If you're going to make rays travel into infinity many directions, well, again, there's no model of creation or where bent space comes from or any of this. So I mean, nobody has a model of what the universe is. So I never claimed any infinitely anything. The idea that the universe is, even if it was just hot, let's just say there was a big bang and the whole thing is dying. The simple argument could be is that it still forms a kind of container. So if there was a big bang and stuff leaves really fast and then some stuff leaves a little slower, you could understand that the slow stuff would end up condensing and it would create a thicknesses like a smoke ring on a bomb, okay? And that if you were inside that area, there's still a lot of heat and energy because there's a lot of stuff. So there's a little stuff everywhere and the energy just keeps bouncing into it. It's theorized that a photon created in the sun, so to speak, released in the sun, spends 1 million years before it can get out of the sun, okay? Because there's so much crap. It just keeps banging into more crap and more crap and more crap and more crap. It just can't get out of the crap. And it's sort of like the argument that the longer you take to get through something, like the higher your velocity, you could argue that if you're trying to get through something and it has a certain amount of matter in it, okay, it has this much matter, and you're going to try to get through it. No, you can't see that. All right. I mean, this is sort of an interesting thought experiment. So there's stuff in positions, and you're going to go through it, and get to the other side. The idea sort of is, I don't know if I should put the stuff in a box, but you get the idea. You're going to go through stuff. Well, it wouldn't matter how fast you're going if the stuff is solid. It's just sitting in one position. But if the stuff is moving, okay, then speed becomes critical. Because then the faster you go, the less likely you are to hit stuff. And the slower you go, the more likely you are to hit stuff. So now speed becomes critical if the stuff is moving. And that's really kind of a fundamental thing in all of this physics, is understanding that relationship between your momentum and what the consequences of your momentum are. Because if this stuff is moving, see, the idea is it's occupying more space per time if it's moving. So it really is like it's here and it's here and it's here and it's here. It's in all of these places in a sense if it's taking you a while to get through, because each one is doing that. And so the positions are creating a kind of, every object becomes this big instead of this big. So where all these little objects were only this big when you were moving, when you're moving instantaneously fast, let's say, the slower you go, the more space they're going to fill, in a sense, through the time that you have to get through. I'm not explaining this perfectly, but the point is that this is like critical to how things function, because momentum really means your likelihood of impact with something. The faster you're going, the less likely it is you can hit anything. All right. If you're going to make rays travel into infinity, so again, I never said anything about there existing any infinities or any of that stuff. Nobody knows the answers to those questions. Nobody can really do any kind of reasoning with it in any kind of fun way. You can only make guesses. So it's not my job. My job is just to give you the evidence. And the evidence is we already know the cosmic background radiation exists. That's stuff that we detected at a frequency. My argument is there's a whole bunch of it that's broken, that the rays are too small for us to detect, and so we don't detect it. There's a ton of it, and it's called gravity, and it's called magnetism. It's called all of that stuff. All right. So there would never be any dead spots. There's no dead spots. So your assumption that there's dead spots is a wrong assumption. It's a false premise. I don't believe there's dead spots. They don't believe there's dead spots. You do. Okay, and you're wrong. Then you might as well call them waves. Why would I ever do that? This obviously won't be your answer. Yeah, it's obviously stupid. How do waves solve dead spot problems? Again, it's just nonsense. What's waving? I mean, there's no evidence the force isn't anything other than a straight line force. Waves go around surfaces. Waves cling to things. Waves do all kinds of stuff that have nothing to do with the physical facts. Maxwell's drawings don't have any waves in them. They really don't. There's no waves in Maxwell's drawings. You have brought up the possibility that maybe force bits get shot back by the edge of the universe. So I brought up the possibility that, yes, if you just turn into a sphere and just say that all the energy doesn't escape, then fine. It just bounces back like a box full of BBs, and so you never lose any of the BBs, and they don't have any dead spots. So it solves the problem you're saying exists. And then I made another counter argument that if you have enough density of matter, you have an explosion and you have a density of matter, well, that matter will contain energy, in the sense that energy won't be able to get past it. It'll keep reflecting inside the container that the matter creates, and so that you can still have an awful lot of heat trapped inside the explosion. All right. Let's see that. Okay, you brought up the possibility maybe force bits get shot back by the edge of the universe. Yes, so it's a container, and so I'm saying that I don't care one way or the other. It's meaningless speculations, in my opinion. It doesn't matter one way or the other. You can still explain the existence of the cosmic background radiation with or without a container. That only seems to solve the problem for the center of the spherical universe. So again, the center is irrelevant. If I dug out the inside of the Earth, there would be zero gravity from all locations, the same amount of exposure to force. I think so. Conventional physics thinks so. You're the one who says something different. All right. Other parts would have gravity bits be more dense. No, sorry. This density issue doesn't exist. from one direction to another. What would cause that? The only way you cause a change in the density, the only way I can, if I go inside the light box, okay, so I'm inside a box, the light sphere. I'm inside the light sphere. So the sphere is producing light from all directions, right? As I pointed out, it doesn't matter if I'm here, I get more light from, more photons from these bulbs, I get less photons from these bulbs, but obviously this exposure is a lot bigger than this exposure, so to speak. I mean, well, technically it's this exposure, okay, is a lot bigger than this exposure. So the stuff I'm getting a lot of light from is very small. The stuff I'm getting a little light from is very big. The two of them equal 0. You know, this will be 1/2, and this will be 1/2, and it'll be 0. Or however you want to look at it, 1. They'll always be the same amount. So no matter where I travel in here, no matter where I go, I'll always get hit by as many photons going this way as this way. I can never avoid getting the same number of photons this way as this way, no matter where I go. Same thing. So like I said, the theory is that if the universe doesn't have a container, the same thing would be happening. All these photons would be leaving over time, and the whole universe would have to freeze because all the energy would leak out into some sort of infinite voyage through nothing. Maybe that's the way it works, but I don't think so. It only seems to solve the problem for the center of the sphere. So there's no sphere center gets more thing. Doesn't happen. Other parts would have gravity bits be more dense. Okay, so that doesn't happen. From the direction or another, there would be a directional bias. So the point what I was making was, okay, it's even if I'm alone. So, but let's say I'm not alone in the box. Okay, so if there's a light box and I'm here and somebody else is over here, now there's a problem, because now though the light going this way, you know, coming through, that would head for me, that would have hit me, but it's not going to now because this guy's in the way. So he blocked that light. It's creating a shadow. So I'm going to get more light from this direction than I'll get from this direction because this guy's blocking a hunk of it. So now it's not 50-50. Now it's going to be less than 50-50. And so I'm going to get more light from this direction, which means I would be pushed. If the light was a pushing force, I would be pushed. That the fact that the sage gravity is mock gravity is again, you're trying to defeat the argument based on something you can't defeat it with because it's already been demonstrated to work. All right, anyway. Other parts would have gravity bits more dense. No, from one direction or another. There would be a directional bias except for the center of the universe. So no, it's not true. I've already explained. It's just not. It's a false premise you've created. One might think that random scattering or redirections could solve this problem. Well, again, there's no need for scattering. There's no need to solve a problem that doesn't exist. Perpendicular redirections that you propose aren't enough to counteract the divergence, though. So again, they don't. Their existence isn't to solve that problem. It exists to explain why there's magnetism, and that's it. It exists because there's a real phenomenon demonstrating that something like it must happen. So it's the explanation for why there is the effect there is, why protons and electrons are attractive and repulsive. At most, 1/2 the perpendicular are going to counteract it. Redirections would actually create even more blind spots between the rays. So again, there's no blind spots between rays. Again, if we reduce this to charges and, you know, Maxwellian style drawings, again, it's just about the divergence doesn't create any absence of exposure except for the appropriate amount of absence of exposure. So the idea is how many lines you're going to intersect. So each charge is creating, you could say, a preposterous number of these lines. So I'm only representing a tiny fraction of them. And the idea is that if you're this close, you're going to intersect a whole bunch of lines. And the further away you get, the less lines you intersect. And there theoretically are places where you might not get hit by a photon from this light bulb in 400 million years. Okay, sorry for the fact that the drawing's not where it should be. So the idea is just this is the measurement. This is an illustration of the inverse square law, is this divergence. And it's perfectly accounted for in every part of my theory. It's in no way avoided or not dealt with. So I just, reflections actually create even more blind spots now. Some get shot back, none catch up. I don't think reflections are rays coming from the opposite side serving as fill-ins should be enough, since they have the same problem with blind spots. So in the interaction between protons and electrons, well, as I pointed out, yeah, do it some more. So he's sort of talking about the idea that I have explained, that the relationship between these electrons and protons is this inverse relationship. So whatever happens to the blue thing, it's the opposite for the red thing. So if blue energy goes into the red thing, it diverts. If red energy goes in, it replaces something inside, and there's a reflection. So it changes the history of this register. Essentially, these objects are collecting a history, so they have stored in them the last millisecond of their existence, and that whatever came in and it has been stored, and what happened a millisecond ago is released. So they're essentially making an exchange, and so it's like a little bit of a storage thing, a unit. So what comes in gets trapped. That trap, whatever was in that trap, is released, and it's the opposite, an equal and opposite reaction thing. But again, the red things deflect the blue things deflect the red, okay, in one of the perpendicular dimensions. But the trick is that sometimes a red thing comes in this way and gets deflected right into the red thing, creating an impact. And sometimes a blue thing comes in this way and gets shot this way, creating some pressure. So these two objects, although they're intensely attracted, because there's no force between them theoretically, because all the force gets deflected, that was heading for them, and some force that wasn't heading for them ends up hitting them, but it's only 1/4 of the force that they are lost. So they lost 3/4 and gained 1/4. So it's a lot less energy, very low pressure here, and so they're driven towards each other. But the point is they won't collide, because to collide there would have to be nothing coming in here going this way and nothing coming in here going this way. So they never really collide. There's always a minimum amount of pressure between them, and that would explain the existence of the neutron. Anyway, alright, so some get shot back. Well, anyway, the other random redirections also seem unlikely to me. Again, there's no random redirections. It's not an issue. We see light from very far away galaxies and get decent images, right? And so I can rag on gravitational lensing or something. That's right, because we use a lens, and so we take advantage of the divergence. So the light coming from the thing is actually going. The image of this thing can be seen here, 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 here. You can go to any spot and you'll be able to see this thing. All right, you're not going to see the same photons. You're seeing different photons. So each location will get different photons. But the idea is you put this lens in here, and so the light goes out this way, and the lens is curved. So these curves bend the light more. Okay, the more curved it is, the more light is bent, and so you're just basically taking an image over here, collecting a whole bunch of its photons over a large spectrum, because they're all diverging. So you're kind of undoing the divergence. That's why how big the lens is matters. The bigger the lens, the more light you're going to collect, and then you're going to converge it back on a focus, your eye. Okay, and so That's pretty simple. And obviously the funny part is the gravity lens is shaped exactly the opposite. It's flat. Okay, it's flat out here, not curved. And it curves here. So it's, it's in no way at all like the regular magnifying lens, in that it bends the light a lot here and bends the light a little out here. So the place it needs to bend a lot, it's bending none. And the place it needs to bend a little, it's bending a lot. So obviously it will not create an enlargement. It won't collect more photons and bring them to a focus. So it can't even work as a magnifying lens. Just can't do it. All right. So reflections for this less evidence than we would expect for this perpendicular. There's less evidence than we would expect for this particular idea. So again, I don't know what all this redirect. I don't need any of this stuff to fix any blind spot. There's no blind spot. The only solution I could come up with, you don't need a solution, but whatever, is that, again, it's called mock gravity. It doesn't need a solution. Is that it works like empty space must spontaneously admit your force bits from time to time. So again, I don't see any necessity to create any such mechanism. Even if the universe is slowly dying, there can be enough energy, just like I said, reflecting off all the other little bits, all the other galaxies and suns and stars. Since you don't like to think in terms of quantum fluctuations, well, why would I? It's retarded, made-up nonsense. Maybe you ought to model this as your spontaneous breakdown of traps. So again, traps where, and trapped how, and trapped when. Maybe these traps would be more minor or less rigid than actual particles. So again, more, I don't need any of this. It's not broken, so I don't need to fix it. Somehow by being too isolated, they could break down in the vacuum of space. So again, this whole idea that vacuums of space do something, that there's vacuum energy, all this, it's just their made up nonsense. I don't need it. It doesn't play a role. There's no function for it. The spread the trap bits into random directions without any discernible frequency. A tiny percentage of the universe's energy is in the form of bits at a rigid period. Tiny, tiny, tiny percentage. Somehow light wouldn't get stuck in these traps, or maybe only the first bit of a photon, so we wouldn't notice. I could argue the traps are, for the electron and proton, have a tiny time scale. Now the traps for the Earth, since it's so big, okay, those traps can be long. I mean, they theorize it takes 1 million years for a photon to get out of the sun. I mean, come on, 1 million years. Mainly force bits traveling along would get stuck. Trap would expand, filling the blind spots in space. So again, there's no blind spots until it collapses. That should do the trick, question mark, maybe. Seems a bit ad hoc and vague. Yes, hey, at least I got no magical pixies involved. He changed this text from the last time I read it. That's funny. Yeah, he did. Anyway, in any case, I haven't seen you tackle this problem yet. So there's no problem. Curious to see your response. You obviously given this way more thought than I have. So obviously I have, and you're being kind of presumptuous, but I'll credit you for writing all this crap. I suppose you should just pose them as questions. Say, but I just, again, you're supposing a problem I can't understand as a problem. You have to deal with something that you can cite in better terms as a problem, because this is there's no density problem in mock gravity. All right, so enough of that, I suppose. I guess we could do the website since I have updated it a little, so we'll deal with some of that. Did some minor fixes to this menuing thing and put in extra as a word, and so now you can hit another menu that'll have links and blah 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 blah. So when I figure out how to reintegrate the tools I've created, I'll put them back in here, and you can obviously, this thing can be loaded on other browsers and all that kind of stuff, and you can pop it into other windows, and it's like over here in the comments section. See, I can just hit the bookmark and I can just pop the thing. Oh yeah, you can't do it in a YouTube comment window. I forgot about that. But some other window will work. Let's see if the upload window works. That'll be interesting. Yeah, it worked. So I can pop it under the other websites, and I can do some little things, black and white it, or crap like that. But anyway, that's, nobody's ever given a shit, so it really doesn't matter. Probably won't go through all that crap. So back to the website page. So it doesn't necessarily look its best in black and white, but whatever. Maybe I'll leave it that way for the reading anyway. Alright, so didn't really change this part, so I won't bother reading that. So I have changed this little, it is proposed that part, so we'll go through it. The universe is in substance just made of one thing. Let's call them force bits. So instead of quantons or any other kind of, I just make it simple, force bits that are always moving the speed of light and come in two types, electron force and proton force. See, this part's going to get redundant. I just realized I say that right there, that probably don't need to say it again. These force bits fill space and are contained, trapped in matter. So I think that's sort of clear, but who knows? And are in essence all there is and all that is. So in a sense, the boats are just swimmers, and well, let's see. When trapped inside electrons, protons, and neutrons, they give matter its properties. So the fundamental laws affect protons and electrons. Electrons and protons create neutrons. Collectively, that package creates an atom, and the atom has properties based on what kind of boats, how the boats are arranged. When they arrive at a precise time interval, we call them light. Photons, electromagnetic radiation. So when the bullets are coming at a consistent frequency distance between them, we can identify that as a ray of light. When filtered for type by a magnetic material, they are called magnetism. So when you make all the black ones, the electron bits go one way, and you make all the proton bits go another way, you create a dipole. When passing atom to atom in a conductor, they are called electricity, right? But there is no electric force. There's just the phenomenon of electricity, and all there really is this charge force, the magnetism force, the fact that the electrons and protons behave inversely. That's the only real thing. When accelerating planets into suns, they are called gravity. When pushing electrons, protons, and neutrons together and apart, they are the strong and weak nuclear forces. But all of those forces are the same thing. It's all charge, realistically. Alright, so 2 plus 2 plus 2 physics. Let's start with a clean slate, a great expanse of truly nothing. Okay, so that should be imaginable. And so they're red and black, not just black, but whatever. The new simulation, I'll put a little simulation in here. A couple more days, it should be ready. A great expanse of truly nothing. Now introduce a very simple something, a dense field of simple little bits that have a short list of simple properties. So these are the little bits, they're red and black, and that's basically what this says. Okay, in open space they move at a constant speed, the speed of light, in straight lines. Okay, they come in two types, electron reflecting bit and proton reflecting bit. Consider the implications of such a field in motion. Perhaps you can understand that it would create a kind of even pressure. So this other guy says basically somehow doesn't see the even pressure coming out of that field, but that's what it would create. At every point in the field would become a point of intersection or convergence. That is, there's a certain number of lines that are going to get crossed, and in each place there would be the same probability of line crossing. Effectively bombarded from every direction. So if you were to place a still object in any position in the field, it would be constantly jostled by pushing force coming from a constantly changing direction. So at any one moment I'll be getting hit by photons from different places, but over time, over any interval of time, I will have the same number of them hitting me from one direction as the other direction. Now introduce a second still object close to the first. And so now we're starting the gravity thing. So I don't know if I rewrote this. Perhaps you can understand that the single objects will be profoundly affected by the other object's presence. So yes, it's in there. It's blocking what would have got to me, but it was not going to get to me now. Now the straight line pressure will not be able to reach all surfaces evenly. This circumstance invents the shadow, and with it imbalance. So now the amount of pressure changes because there's more stuff hitting me from one side than the other, and with that movement. And yes, force causes movement. Through this mechanism, the material universe is pushed together. So the electrons and the protons are pushed together. Well, the electron, everything's pushed. The electron's feeling the pressure, the proton's feeling it, the electron and proton together are feeling it, the atom is feeling it. It just extends. The pressure's coming from the outside in. Everything's being pushed together. But it all starts with a tiny universe. Not so much by the presence of force, but by the shadow of absence. Okay, so now the rest of this I got to rewrite still. So anyway, that's it for that. So we'll do a couple of definitions and get the hell out of here, I guess. All right, so what is a ray? So I thought I would try to explain. Try to define these more ambiguous kind of concepts. So these are, I haven't really started to get to, I haven't finished these definitions. Let's see if there's a way to, let's see if I turn the menu on. Okay, that worked. Turn it off. That should stop this from happening. Sorry, the screen was going to go out. Alright, so what is a ray? Most elemental form of travel. So that's what I would argue. It's the simplest you can get, right? Point A to point B, straight line. The line. Simplest thing you can make in the universe. That's it. So that's, credit to the ray. It's simple. A straight line traveling a vector. Okay, so that's another more specific way of saying it. The volume can have a period frequency, I guess I need an A in there, that is constant or inconsistent. So the stuff, raying, the stuff coming from some place or anything on this line, it can come at precise intervals, or it can be, imprecise intervals, different intervals between each exposure. And if it's precise, then it's something we can detect with certain instruments. If it's not precise, we can't detect it. Something that moves from point A to point B in a straight line ray. Okay, so that's just another way of defining the word. That's as far as I got. Not very far, right? Because what can you say? All right, so what's a wave? All right, the first argument is it's not elemental. It's got to be made of something. There's got to be some sort of structure. A ray is simple. Just can have something moves from point A to point B. It doesn't matter what the thing is, and it'll move in a ray-like fashion if it moves from point A to point B. Where a wave has to be made of something much more complex, and traditional waves anyway. And if you convert the wave into a bunch of particles, then you're just back to making rays again. Okay, an emergent composite. It's a bunch of stuff. So I guess the key is I should state for rays is that rays can be just a single object moving through space. Most often spreads in directions tangential to travel. So that is all the signatures of waves are the fact that it turns into this idea of a bunch of things moving, in different directions and spreads. It's just hard to come up with a really great definition. Wave spread can be the byproduct of diverging rays. So that's the funny part, is that these really aren't dualities, because the wave is clearly kind of just a byproduct of. You could always draw a wave as a bunch of rays causing the wave. Can be the byproduct of an overlap. So in some sense you can think of waves as pressure, and pressure is created by the fact that something occupies a space and then something else tries to occupy its space, and so it doubles the stuff in that space, and then that doubling doesn't work, and so it gets pushed to the next guy, and then the next guy's getting doubled, and then the next guy gets doubled, and the next guy gets doubled. So you can think of a wave in that sense. Right. Occupying some other thing's space. Waves do not land in one location. Well, that's the key to most all wave behavior would be, is that a wave doesn't just go from point A to point B. It goes from point A to point A, B, C, D, E, F, G, all kinds of locations. That it's a group function, not a single object function. That's as far as I got. It really is a tough one. I don't think I did much modification to these. A field of imbalance for energy. I prefer to say that energy is the force bits moving. That's energy. It's momentum in the universe. That's the energy. But we always use the word energy to describe systems that are imbalanced. We don't use it to describe we use it to describe systems that have something, something has to be revealing the energy. The energy has to be seeable. And you don't see the energy like when you're in zero gravity between the moon and the earth. You're not seeing the energy. You're in plenty of energy. You're gravitationally being affected by both objects, and the field pressure exists. It's just that it's neutralized by balance. So it's, we only call it energy when it's imbalanced. When the energy is imbalanced, we call it energy. Yeah. It's kind of funny. So when we see imbalance, we call it energy. But the energy itself is the momentum that's innate or fundamental to the universe. Okay, what is a field? There's only one field, and it's of force, and it's made of bits. Okay, fields are stuff moving fast that move other stuff more slowly. Okay, that's another way to look at it. Obviously, it's a field. The field is of something, and something containing this property of momentum, this property to affect something else. And then a momentum would be the ability to transfer your momentum, your movement. You really don't have momentum if you can't transfer it to something else. Then you wouldn't call it momentum. So anyway, there's no point in going through all that. Some of it I already went through, and I need to improve it for there to be any point in going any further with it. So anyway, like I said, a couple of days the animation should be revealable, worthy of. Maybe I'll show you some of the stuff moving around, but I mean, it's as yet the full mathematics hasn't been imposed yet of the properties of the electrons and the protons, but the field energy part is done, and it's just fun to look at. So anyway, next time and such. So I think that's all there really is. Nothing much else to comment on. I mean, Bill Gates made another video saying particles can't work. Apparently, I did post my link on his video, but he doesn't respond unless you join Patreon. I'm not joining Patreon. I think it's capitalism at its worst. So fuck that. But whatever, somebody else wants to just comment to him that I did respond to his points, and he's so far ignoring that. So whatever, we'll see what happens the next time. But he just keeps making the same arguments that, in my opinion, are stupid. I mean, they've been accounted for not just by me, but by other people arguing particles. I'd say most of them aren't arguing it very well, so I'm the only one doing it well. But anyway, so that's all. So till the next time, and such. Yeah. That'll do. It'll have to. For today. Anyway. Yeah, I think that's enough. Yeah. Oh yeah, on the website I did want to point out. Go there, please. So when you do click this extras thing, I do have the definitions video and the 2 underview and overview videos there, so they are accessible there. But anyway, just pointing it out, and such, so forth and whatnot. So till the next time, and such.